Graphing polynomials is really, really important. So when we graph polynomials, when we deal with the polynomials, what do we know already? What do we know about polynomials? What's the word poly mean? Nomials? Yeah, numbers or many powers, okay? So the polynomial, or the order of the polynomial is determined by the size or by the largest power. Does that make sense? So if I look at, I mean there's only one power in this, but if I look at this function, what order is that polynomial? Order 4, correct? That's an order. And if I had x squared, would that change that in that one? It would still be an order 3 polynomial, correct? Polynomials, just for revision, what can they not be? Hayley, what can they not be?
Negative.
They can't have negative powers, and they can't have? They have to be, starts with I? Yeah, whole integers, correct? Whole positive integers. The coefficient of the first term must not be, but anything after that, we're all good. Sweet? That's just a recap on what polynomials are. So when we sketched our rough, can we just trace with our finger our order 2 polynomial? How does that look? Everyone get your fingers out, I want to see how they look. So either smiley face or sad face. Obviously they're all smiley faces because we're in mathematics, and what better place to be? Sweet. Our order 3 polynomial, what's that look like? So I'm seeing, keep tracing it. Yep. No? Oh, yeah, sort of. I don't know what that is. It's a bit of a square. Yep. That's a circle, but nice try. We're almost there. Okay, good. So they should be either like so or like so, correct? Something like that. If you had a flat point in the middle, are you wrong? If your function looks like that, are you wrong? No, you are still correct. You are still correct. Okay? You're not wrong if that's what your polynomial looks like. It's just a different, slightly different style. Order 4. We haven't seen these before, so how do we think they look? Let's see those again. So some people have got big, sharp U's. Any other ones? Oh, what did you do that? What was that, Abby? Up, down. So you finish like this. Is that what you're saying? Like an M?
Yeah.
Yep, like an M. So you could have had a steep, really steep U. You could have had a W. Or you could have had an M or a really steep N. All of those are appropriate. Happy with that? Now this is probably a good point. Does that look like a bridge?
Yeah.
Does that look like a bridge? Does that look like a bridge? Just a little hint, alright? Your order 3 and order 4 polynomials are looking splendidly close to your bridge. If we look beyond that domain, it probably doesn't suit your data quite as well. Whereas our lovely friend, the polynomial, it just keeps on tracking beautifully like a suspension style cable. What do we notice about the following? What do we notice about the following? Now, what I care about here is the shape, the range. What's the range again? Possible y values and how steep. Sweet? So let's just go from the top. X minus 4. Tell me about the range of that function. Where does it go on the y values? What is that function? Starts with L. Linear. Okay, it's a linear function. Can it be negative?
Yes.
Can it be positive?
Yes.
So it can be any number for a range, correct? Correct? What's it look like?
Straight line.
Straight line, so there's no curve in it. How steep? How long is a piece of string?
1.
Well, that's the gradient is 1, correct?
Yes.
Relative to the other functions though, is it steeper or less steep? Less steep. Does the amount of steepness change as the graph goes on, or does it stay the same forever? It stays the same. Very good. X squared minus 4, what do we notice about that graph? Can it be anything? Is its range anything? Some say yes, some say no.
It could be higher than the turning point.
Higher than the turning point. Where is the turning point?
Negative 4.
Negative 4. So the lowest value this function could possibly equal is -4. Interesting. So it's kind of gonna. It doesn't have any range, does it? Was that an even or an odd function? Is the order even or odd? Even. Okay, so this has got, I'm just going to write range. We know what that means. It means something about the range is different there, correct? And I've underlined it because it's an even function. How steep?
Isn't it like exponential until it gets over?
It does get steeper as it goes along, correct? It just keeps getting steeper. Steeper than x minus 4, correct? There is a change. Number 3, x cubed minus 4. Tell us about the range of that function. Can it be anything?
Yes.
It can be anything. So it's a bit like that first one, correct? It can be anything. What do we know about the steepness?
Pretty steep.
Pretty steep. And she's got that, I don't know how you describe it, sort of like an N with a tail at the top. I don't know. I don't do art. Lightning bolt. There we are. It's a lightning bolt shape. There. Our last one, is it an even or an odd power order?
Even.
Why is it even? Why is it odd? Why do you think it's even, Harry? 4. Very good, you're correct. It's the pair of 4 and 4 is an even number. What gives you the range of this function? Can it be anything?
No.
Why not?
It's even.
Yeah, and where are they going to occur? Yep. So it can only, the lowest value can possibly equal us? -4. So it's got another range constraint, doesn't it? Why does that happen? Why have I noticed? What would happen at 6? Do you reckon there'd be a range constraint?
Yes.
8?
Yes.
Why?
Because when it's actually the negative numbers even power, it becomes positive.
Very good. What's -5 squared?
24.
Positive 25, correct? Any negative value to an even power is going to give us a positive. What about a negative to an odd power, like a power of 3? Negative value. Does that make sense? So every even power will have a range cap. Where will that range cap sit? Where will it not be able to go?
Past -4.
In this case, past -4, which occurs at our turning point. Does that make sense? Does that mean that you can never get an even function that's negative? An even power that's negative? What if I put a negative here? What would happen?
It's kind of
What's it going to be? Is it going to be a happy parabola or a sad parabola? Sad parabola, correct? So it can never be positive. What value is that? When I look at my translations and transformations, what value am I changing when I change the happiness or the sadness of the parabola? The A value. Call that dilation value. Are we clear with that? So that's a good little start on range